This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Lee Bortons, and it's Wednesday, August 21st, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for classical conversation students in rural communities. Our club is preparing for our first semester, which many of you have just begun with our students, and so we're working on a lesson each week. We hope to highlight strategies for leading our children through the math map this coming year. So, Christy, what do you have for us today?
Well, we are excited to be moving on to lesson 4, addition and subtraction. And so for those of you who maybe wondered in lesson 1, where's the math? And then in lesson 2 started going, okay, there's some numbers. In lesson 3 started to see some comparison. We're finally going to start operations today. And so just a reminder that all of our domains are going to be working on addition and subtraction the same week. So whether you have naturals, fractions, complex, or digits at home, you can use any of those to follow along with our Math Map Book Club. And also, if your students are in community, they will need complex this year because that's the only one that has all of the parts with it. But they can certainly be using any of the other domains at home and still be proceeding and progressing along with their classmates. So as we do every week, we want to start by taking a look at our math map and making sure that we know where we are. So if you look at the cover of your book, you'll notice on the left-hand side, you'll see a color, and you will see a title on the left-hand side. So if you are in complex, you have this gold, fractions would be this green, naturals, the red, and digits, the purple. We are all, whichever domain we're in, we are all in lesson 4, addition and subtraction. So that's why we're going to go ahead and put our check mark in this box. And we want to just remember that we are in 1D, which is represented by a line. So we can each week remind the students and ourselves what dimension we're in. All right, and everybody's favorite part of our week is when we get to play National Number Knockout. So I'm going to start our timer. Your numbers are 5, 2, and 1.
Five times two is 1 is 8.
5 times 2 is 10 plus 1 is 11.
5 squared plus 2 squared plus 1 is 30.
It's okay to give more than 1.
5 squared plus 2 squared times 1 is 29.
5 times 2 minus 1 is 9.
5 squared plus 2 is 29 plus, 27 plus 1 is 28.
The 5th power of 2 is 32 plus 5 minus 1 is 36. No, I did that wrong. 32 minus 5, 27 times 1 is 27, or plus 1 is 28, or minus 1 is 26.
5 plus 2 cubed plus 1 is 16.
5 minus 2 squared is 5 minus 2 squared, 4 is 1. And then times 1 to the first power plus 1 is 2. So 1 and 2. Yeah.
All right, great job. All right, so we've got our computation brains warmed up. Let's go ahead and take a look at our cover. And so we have a piece of art here, and let's go ahead and we're going to take a couple of minutes to talk about our piece of art, and then we're going to take a look at our quote by Antoine de Saint-Exupéry. So what do you guys notice about this piece of art, and why do you think it was chosen to represent addition and subtraction?
The lily pads look like a number line.
You
And
could
then
add,
for all the birds in the sky.
Yeah, he's hopping from point to point.
there's lots of things to count.
There are lots of things.
I wonder if the
And there's-
squiggly lines could maybe mean equals or approximately equals.
I like how it looks like the hops, like how we do the hops in the practice pages.
The artwork itself looks very simplistic and almost like young childish, which makes me think of addition and subtraction being some of those early foundational stages of our math computation.
The lily pads look like greater than and less than.
A horizon line could also be like the 0 point on a number line. You can see the reflection of the tree on the bottom part, so reflecting that a little bit.
The frog could move in either direction. It could go up for addition and backwards for subtraction.
This isn't so much math related, but I went over to the companion guide and noticed that this was done by a challenge student. I'm assuming related to Kirsten Gilpin, since it's by Kate. I think that's kind of cool and something exciting to share with our students.
That is my daughter, and she named it for Lee's granddaughter, and because Lee loves frogs. So there's lots of tie-ins for this particular piece of art. She was much younger when she drew it, though, so now she's somewhat critical of it.
You could note that some of the lily pads have a flower added to it, and some of them have a flower subtracted.
Ooh, like that.
A little more abstract, but I see the branches on the trees are not yet in bloom, but there's that anticipation of further growth coming.
I think I like that it's not, the lily pads aren't in perspective, so they're up like this, so you can actually see that more clearly. And I think a child would find that interesting. They wouldn't think about it necessarily, but they could see the lily pads more clearly, and it just makes it a little interesting piece of art. So it's nice.
The opening of the lily pad is being rotated.
I noticed that the trees or the branches are reflected as mirror images in the water. So maybe that would relate to the commutative law, maybe, regardless of that, even if you mirror the ideas on either side of the equal sign, they're the same thing.
Great.
Someone had mentioned that the lily pads look like greater than or less than signs. I was thinking that that missing chunk was like a subtracted part that shows a fraction of the lily pad being removed.
The frog also has like a shadow cast below him, so it looks like maybe it's like noon o'clock.
I like that. You guys are doing a great job. And I think one of the things I like about all the different things you said, from, hey, we can count the items that are on this, that might be something that's really accessible to our younger students, to older students saying, okay, well, what are the laws that are represented here, right? That we're going to see, oh, yeah, I'm sorry. I never started the timer. So I'm keeping time on my watch, on my phone, however. So sorry, you don't get the countdown. But the art is the same every year. And it may be tempting to think, oh, we talked about this piece of art. But I just wanted to take a minute and invite, I know Babs is here, and I don't know if any of our other pilot tutors are here that maybe have talked about the art for more than a year with the same group of students. So I'm just going to pause for a moment and see if there's anybody that wants to chime in about how even the same group of students seeing the same artwork year after year actually leads to deeper conversation.
I mean, it definitely does. And I think not necessarily that they go deeper, but it's just different. Like they're in a different place, right? They're a year older, they see things differently. So even though they might have seen this artwork before, they're not going to always see the same things.
Great. That's such a good point, right? That they will be a year older. Thanks, Jill. Yeah, and there's a familiarity, right? That they go, oh, I remember this from last year, and so that's going to help introduce that familiarity year after year, seeing the same piece of art. Let's go ahead and talk about our quote. Jill, would you go ahead and read our quote this week, our quotation by Antoine de Saint-Exupéry?
Yes, and thank you for pronouncing that before you asked me to do it. In anything at all, perfection is finally attained, not when there is no longer anything to add, but when there is no longer anything left to take away. Antoine de Saint-Exupéry.
All right. So what do you think about that quotation and how that might relate to addition and subtraction?
Well, I think that it reflects what we see in the Bible where it says, put on Christ and put on these things, so that we are adding to what we already have of good things, adding good things.
In the same train of thought with that verse too, just putting off the old. So I love that this emphasizes that really the importance is taking away. And when there's no longer anything left to take away is when you reach the perfection.
Yeah, because that implies that there's always something to learn. We can always grow, go higher up and deeper in and grow more like Christ, but we can, once we've gotten rid of the things that need to get rid of, that's when we've arrived, even though we haven't arrived.
What do you think is harder, the putting on or the putting away, the taking off? Which do you think is harder?
The taking off.
Taking off.
Yeah, sometimes we cling a little too tightly to those things that we need to let go of.
Yeah, I'm kind of like Jill. I think it depends. I think it depends on what season you're in. I think sometimes it's easier to let things go, and then sometimes it's harder to let them go. So I think it depends on the season you're in.
Is addition or subtraction harder? Which one do you guys prefer? Which one would you rather have to do?
I'd rather add.
Addition.
Yeah,
Do you think it works a different part of the brain? Do you think addition and subtraction work different parts, or you think they're the same?
Ooh, that's a good question. I would think it's the same, but I think there's a sense of moving forward and adding is easier than moving backwards and deconstructing, perhaps. Right. I mean, if you think about baking a cake, it's a lot easier to see what your ingredients are and put them together and bake the cake. And it's a lot harder to eat a piece of cake and go, oh, I recognize this in it, right? More often we're going, oh, I think it tastes like, right? Did you put what's in this? That we're trying to figure out what went into a cake. But if we know what the ingredients are, it's a lot easier to put it together. All right, great job today. And I love the fact that we can, right? We immediately jumped into this great spiritual conversation about perfection and how math, right, can make that conversation a little bit more accessible, because what is it that we're trying to do? So thank you for engaging with me. All right, let's go ahead and turn to our I² invention page. And there's a lot on this page. And today I'm going to invite you to think about circumstance. That's not one of our common topics that we perhaps have looked at a lot. But I would like you to think about the circumstances. Just looking at this page, and you're going to have to do some comparison, perhaps, in order to determine the answer. But under what circumstances are circles open or closed when we're graphing with them? So I want to point out to you here, this section in the middle right here. And I'm sorry that I have those weird squiggles.
It's closed if it's also equal to that point and includes that point.
Good. So when the endpoint is included, right, that's our circumstance. That when it's included, then we color it in. And if it's not included, then we don't color it in, right? So if we know that, let's look at our example number line here. And tell me now which of our endpoints are included and which ones are not.
If there is a parentheses, it's the one that is not included. And if there's a bracket, it's the one that is included.
Yeah. So which ones are included? Which endpoints are included?
Are you saying like 2 is open?
Yeah.
Versus 5?
So which one? So 5 is closed. So which one is included in our set?
5.
5.
So
yeah.
So the 5, the 10, the 13, and the 16 are all included.
Yep. Excellent. Right. So there we go. So we just looked at, right, the circumstances and made a determination. Good job. So let's go ahead and also look at a definition question from this page. And how would you look at this page? How do you define domain? So we've talked about it before, and now we see that it's again on this I² page. So how could you can use something that's on this page or something that you know, how would you define domain?
It's a set of numbers.
Okay.
So from this page, could you say it's a set of consecutive numbers?
It might be a set of consecutive numbers. Does it have to be consecutive?
No.
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 It's the input, not the output.
Good. Input, not output. So now let's go ahead and think about that idea of domain that we're using here on our I² page that we've just defined, right? That it's a set of numbers that's used as input. And now I want you to think back to what domain of the math map that you have in front of you. Right? So you either have digits, naturals, fractions, or complex in front of you, and what types of numbers are in your domain, and what does that mean? What kind of numbers are you going to calculate with?
So with complex, you're going to be using some imaginary numbers.
Good.
I have fractions in front of me, and so I also have integers, fractions. I also have imaginary numbers on here, and trying to think what else. There's no decimals on this certain page, but I know they're in here.
All right, good. So you notice that you have some subdomains and you're being introduced. You probably aren't necessarily calculating a lot with domains that you haven't gotten to yet, but you notice that those subdomains, if I'm in fractions, that decimals and naturals and integers, and are some of the other numbers, right? So if I'm in complex, you're going to see all kinds of numbers, right? We might see some real numbers, some imaginary numbers. So when we look at this page and we've come up with this definition, right, we can see how that's also helping us to understand what it is that we're doing every week. Let's go ahead and look at our Memoria page. I'm going to give you a minute to look at this page. And what is this page about? What is it that everything has in common? What have we arranged into groups on this page?
Patterns.
Patterns, good. So all kinds of patterns are on this page. So let's go ahead and look in the middle section where it says iterative addition sequences. Right. And we're not gonna necessarily talk about exactly what all those words mean today, but let's look at those three sequences: triangular, hexagonal, and Fibonacci. And if you were to choose to memorize these this week, I want everybody to think back to last year when you were still in foundations, and I want you to think about that amazing foundations tutor that you had. And if you were practicing these in your foundations grammar time, what are some things that you would do to help yourself memorize the triangular, hexagonal, and Fibonacci numbers?
Sing a
I want a
song.
song.
All right, great. So we're going to sing a song. What are some other things we might do?
Repeat them 7 times out loud.
Okay, good job.
Our campus had a dad that did one of the foundations classes, and it was all boys, and so they did ninja math, and they would do a different, like, I don't know, karate chop or something. That was kind of fun.
Good. So we can act out some different things here.
Always like a hopscotch where you're just jumping from one to the other and repeating it out loud.
I think find a pattern so it'd be easier to recognize or easier to know what you're looking for.
Good. So you're noticing, hey, I could use this pattern and I could memorize the pattern instead of necessarily the sequence. That's a good strategy. What's something you could do at home that we may not have done in community, but when you go home, what are some things that you could do to help memorize this?
I think explaining to a sibling or a parent what you learned is really helpful in learning.
Great. So copy work and reading this to somebody else. So those are all great strategies. So I want you to be encouraged as you listen to everybody else today and pick one of those to go home and practice memorizing these sequences. And when we're practicing memorizing, remember that this is our Memoria and our arrangement page. So we can look at things and how they're arranged, but we're also looking at things that we can start to add to our Memoria. So remembering all of those skills from foundations, right, is going to help us build our memoria and help us to figure out, right, how we could memorize things. Right. One thing nobody ever said, could you make flashcards with these sequences?
Yes.
Yeah, right. So just like we are making flashcards every week with our Latin words, we can make flashcards for things that we encounter in our math text that we're not familiar with. And that helps us to come back and to practice it.
Oh, Kirsty, I wanted to share last week real quick. In my Challenge A class, I had kids do that. They picked some things on this page that they liked and they made little index cards.
That's awesome.
I'll say with some of your NEH student, you could use a geoboard and draw some of these with rubber bands.
All right. So all kinds of great ideas. Good job, everybody. All right, let's go ahead and move on to taking a look at our charts. And remember that there's a lot of information on our charts, but we don't want to be overwhelmed by how much there is here and shut down, because this is our goal for us to become familiar with these charts over many years, right? So nobody is going to master everything on all of the charts, and nobody's going to memorize all of the charts. Somebody might, but I think that's not likely. But we do want to be familiar, because the charts are our big map of mathematics. So if we can remember, oh, I remember where that idea was, it was on this chart. Now we're starting to build that mental math of where things fit, right? And where things fit. So one of the ways that we do that is by looking for the things that are familiar and using those things that are already familiar as a bridge to the things that are unfamiliar. So let's go ahead and take a couple of minutes for everybody to pick out some things that are familiar.
I recognize the line segments rays. I don't know which is which, but I definitely recognize them.
See, I'm starting to recognize those capital NZQRCA. I'm seeing a lot, so I'm starting to just be able to read them.
I see some laws that we talked about, commutative law, associative law from our foundations work.
A lot of the terms like add in, sum, minuend, subtrahend.
Yeah, we had to work with those limits and how to say those sentences that have the word limit in them. So that looks familiar now.
Okay, so now we haven't done this before, but I'd like everybody to pick one thing, right? And it doesn't have to be like a whole big thing. It could be one small thing, but I'd like you to pick one thing from the charts that looks interesting and you think maybe I'd like to know more about that.
At the top where we see the number, or we see the line notation, and it says 1D, and then it says A with the superscript of 1 with that same line, and then X with the superscript of 1 equals X. I feel like I should know that because it's in bold and it's at the top. So I feel like I don't understand why I don't know what that means.
Nicole, you're going to make Lee so happy because she worked really hard to indicate on the charts and on the lesson pages, right? So that you can look and know where you are on the math map. And so we see here on the, that we have our weekly number is there. So we're in week 4, but we also have that information there that we're in 1D, right? That this is a lesson that's in 1D. It's represented by a line. So that gives us our grid. And then we're reminded that in 1D, we might have the first power of a number. We might have the first power of a variable, and that the first power of anything is itself, right? So the first power of X is X. And so there's just some key ideas there from looking at our dimension that we're putting there. And right now we just see that X by itself. When we get to 2D, right, try to remember what you saw here in 1D, and we'll come back in 2D and we'll see how that changes.
So that's not an equation.
It is not intended to be, other than the first power of X equaling X. So what we're trying to show you there is that we can have the first power of a number, or we can have the first power of a variable, which would just be itself. And we'll see, like I said, we're going to see that that notation changes a little bit as we move through the dimensions to talk about different things. And we're going to see that where we look at that number here, the first power of the number is going to represent a one-dimensional measurement, a length. And then we just have the one variable X in 1D.
So the line with the arrows on the end is the notation for one dimension.
Yes.
I feel like I should know that. I feel like I've seen it a million times and I should know that. So okay, we're getting there.
There you go. Well, that's a perfect, right? And that's what we want our kids to say. Well, I've seen this, but I don't really know what it means, because sometimes it takes us seeing things. And then finally we go, well, wait a minute, what does it mean? And now we've got a familiarity with this, with what we're seeing to add the words to. So that's great. I thought that was a perfect thing to bring up. All right, let's go ahead. And if you haven't noticed, I'm speeding us up a little bit than we might be if we were in our community every week, because we do want to make sure that we're giving people ample time for questions. And so we will have time for general questions at the end, but let's take a few minutes now and answer any questions that you have from week 3 or lesson 3 comparison.
We were working through last week and we finished our careful calculations, and it said to look for the answers in the travelogue, not the travelogue, the companion. And I was unable to find those. Can someone direct me where in the companion those are?
Sure. Babs may be able to put a better answer, a more complete answer. But if you go into the companion and you click to that careful calculations page in the companion, and you literally click on that page, the answers will show up on the right-hand side. And Babs or Shauna can maybe give you a screenshot or something that's got a little bit more depth of explanation.
I have a question about the number lines. Often we're asked to say, okay, what is the line and what is the label on it? And I think almost every time the line was R, if I remember correctly, and then it's the labels that change. How come that's the case? Why is it always R? And is there other options or?
So there are, yes. So these are the 2 number lines that you're really working with. And we've used other scales, but the 2 number lines that you're working with, you should have seen this one and this one. All right, so we have our real numbers and our imaginary numbers. And in 1D, we're either looking at our reals or we're looking at our imaginaries. We're not looking at them together. Both of them would have an origin, and we're going to find out that origin eventually is going to be where the 2 intersect. But for now, we're looking at them separately. Notice that I drew a solid line, right? That there's no empty spots on either of these. That's why we say that it's the real number line and it's all the real numbers. It's full, right? There's no empty spots, so every real number. And there's a 1-to-1 correspondence between the reals and the imaginaries. So if I have pi, I also have pi I. And if I had negative square root of 17, I'm going to have negative square root 17 times I, right? And so the line itself, because there's no empty spots, it is the reals or the imaginaries. Every single one makes up that line. But when I look at my labels, and so I'm going to draw a new one here so I can look at my labels. right? I'm only looking at certain discrete numbers. I can identify the numbers. And so there are holes in between my labels. And that's why I can say, for example, my labels here are the natural numbers. Or when we're looking at I, we talk about the coefficients just so that people can see what we're doing, right? So here's my 0, 1i, 2i, -1i, 2i, right? So our coefficients there, because our imaginaries aren't broken down like our reals are, they're just the imaginaries. We would say that our coefficients in this case are elements of the integers. So that's the difference between the two. If I was to say my real number, well, it wouldn't be my real number line. If I said my number line was just the naturals, all I would be able to do are dots, right? 1, 2, 3. And there wouldn't really be a line. In order for us to draw the line, it has to be the reals because it has to include all of those points. Does that help?
That's amazing. Thank you. But I still have a question about the I. Isn't the imaginaries like a square root of -1?
Yes.
And how does that translate onto the number line? I feel like my brain is going to explode.
Okay, so I missed, how does that translate? I'm sorry, to.
Sorry, my brain was in the middle of exploding, so that was that noise. Sorry. How does the idea that an imaginary number is the square root of -1, how does that play out on a number line that's all imaginaries? Is there other possibilities of imaginaries other than the square root of -1? Or I'm not catching that part.
Sure. So 1i, right? This is the square root of -1. 2i would be the square root of -4, right? And so every real number has a corresponding imaginary number, right? And so if I took my real number line and I just rotated it and I said, now it's imaginary, every single point is going to have a corresponding imaginary number. And we can say that any number, right, the square root of any negative number, I'm just going to use a, right? Well, if I pulled out and said, this is now the square root of -1 times the square root of a, here's my real part. This is my, and this becomes my I. And I'm not going to get too far ahead, but when you get to lesson 27, we're going to discover that in 2D, right, these two things, we're actually going to discover it in lesson 9, but we're going to really come back and look at this in lesson 27. We have our coordinate plane, and we're going to discover that multiplication actually is a rotation. So if I had 1, right, and I went 180 degrees, I would end up with -1, and another 180 degrees, and I end up at 1, right? So here's one of my square roots of 1 is -1, right? And so if you look at that and you say, well, I'm kind of going halfway to 1, right? Well, what if I only wanted to go sort of a quarter away? Well, -1 times -1, that's 2 times, right, that I would have to get back to 1. Well, what's kind of halfway in between there, right? So if this is 1, right, that was my 1/2, my square root of 1. Well, half of a half is a fourth, right? And so that's where we kind of come to here, and we only went a quarter of the way to get to -1i. And we look at a lot more in lesson 27. And so I'm not going to get too much more into that because it's a conversation all of its own. But you'll see where this idea of rotation, right? I only kind of went halfway, so I need to get half of -1 now, right? Gets me back to -1i.
Okay, thank you. That was amazing.
That's very difficult what Chrissy tried to do quickly. Don't worry about what she said if you didn't understand it. Your first job is to practice drawing and reading the graphs and practice learning what the notation is. And then in small ways, work on it till you begin to see the calculations. And then later, you'll get the concept. But you won't get the concept till you spend time with the imagery, the words, and simple calculations. it's hard, some of these things.
That's so
Thanks, Kirsty.
But just remember, right? So these are ideas that we're looking at in 1D, right? And so you're looking at this and you're just wrestling with these two different axes separately. And then in a few weeks, we're going to get into 2D and you're going to get to explore these ideas again, but now seeing how they intersect. And then we're actually going to skip in 3D. We're not going to talk about imaginary numbers very much because there aren't any three-dimensional imaginary numbers. That's a conversation for another day. And then we're going to get to ND eventually, and we're going to spend a whole lesson back in really immersed with our imaginary numbers. So one of the beautiful things about the dimensional setup of the math map is that we're going to be able to look at things in a simpler way and then in a more complicated way and continuing to add those layers. So just as Lee said, focus on the grammar for now. These are great questions. We can talk about them here, but I wouldn't bog your students down at home. And I certainly wouldn't expect a challenge director to be talking about this in class, right? So as challenge directors, I've gone off script, right? I'm not modeling well for you, because if you're a challenge director, what should you be doing? You should be helping the students to say, okay, we're going to look at comparatively. How come this is the way it is? And let's look at our answer key to help us figure that out. So we want to help our students do that. And I am not modeling that for you. So I just want to be really clear that what I'm doing is not what your challenge directors and tutors are doing. All right.
We love your enthusiasm, Kirsty, and willingness to go dive deep. It's really encouraging to see just in this dimension so many things. So thank you for doing that.
Is it all right if I ask a question that's from lesson 2 instead of 3?
It is, but I am going to ask you to hold that question because we're going to have time at the end. So if you could hold that, and Nicole, I will remember to come back to you first at the end. So as we've talked about before, each week we are going to be going through the lesson tops. Now, if I was tutoring in community, I might go through 2 or 4 of these alongside the students before I challenge them to do some on their own, because we want to make sure that you have time for your questions. I'm just going to go through 2 with you today, and then that will hopefully leave us more time for questions at the end. So let's go ahead and jump into this top of page 1. And our instructions say to match the underlined terms. So I'm first going to read what's underneath that. And it says that addition equals an addend, or is an addend plus an addend, which equals a sum. And subtraction is a minuend minus a subtrahend that equals a difference. And I see that some of this is already done. And so the example that's done is working from the middle column top down. So I'm going to go ahead and work that same way. So I see here that my A and my B are underlined. So by looking up above at addition, I see that addend and addend are in the same place as A and B. And so that's what I'm matching to. If I look on the right-hand side where there's an example, I see again that it's this addend location that's underlined. So that would be my 65 and my 35. Below that, I have A plus B equals C, but now my C is underlined. So I'm looking at addition. So I come up and I have addend plus addend equals sum. Positionally, sum is in the same place as C. So C is my sum. And on the right-hand side, I want to look for where that right-hand side is underlined. And there's my sum. This was just a errant mark. Below that, I have A minus B equals C. And so I notice first that I have a difference here. So I'm going to look at my subtraction, right? I've got a minus sign, so I'm going to look at my subtraction. And my A underlined, that's in the same position as minuend. So that A is my minuend. And on the right-hand side, I want to look for, again, that same position, right? The first one, that's my 55. So I'm going to match that to my 55. The second one, A minus B equals C, my B is underlined. That matches up to be the same position as subtrahend, which is my second number. That would be my 20. And then my last one, my C is underlined, which is in the same position as difference. So I'm going to match to difference and to my 8. So I'm using my skill of comparison. Below that, we're asked to sketch the hops and plot the solution and begin with the first addend. So what's my first addend? It's 0, so I'm going to start at 0. I'm adding 3, so that's one hop that has a length of 3. I'm going to go ahead and trace my 3. And my solution is 3, so I'm going to plot my solution. This is a line, so it's my real number line, and all of my labels are natural numbers. Below that, we're told to begin with the minuend, and we're doing subtraction. So go ahead and look at above, and what's my minuend? Right, it's 3.0, so I'm going to start at 3.0. I'm subtracting 3, so I'm going to move left, because remember from last week, my subtraction or my negative is telling me to go left. It's going to be a hop of 3. So 1, 2, 3, and that gets me to 0. And that's my solution. So my line is the real number line. This time I have negative numbers, so my labels are integers. As we look on the right-hand side, do you notice how similar these are between my reals and my imaginaries? So I'm going to take what I learned there and bring it over here. And I see here that I start at 0 and I'm adding 0.3. So I have one hop that's 0.3 long. And my answer is 0.3i. Then I start at 3/10 I, and I have one hop that's 3i over 10, or 3/10 of I. And I'm going in the negative. In this case, it's going to be a down direction. And so one hop gets me to 0i. And my coefficients on both of these are going to be my rational numbers, and my number line is the imaginary number line. Let's go ahead and look at page 2. And I'm going to give you a minute to find the sums that are on our left-hand side where it says plot. So go ahead and take a minute and add 7 feet and 3 feet, and then 83 inches and 45 inches. So when we add 7 feet and 3 feet, we end up with 10 feet. We want to keep our units. And then 83 inches and 45 inches is 128 inches. And then it says to plot. So I'm going to plot my feet on the left-hand side, and I'm going to go ahead and put a mark at 10 feet. And then on the right-hand side, I'm looking at 128 inches. So this is 126. So a little bit above that is going to be 128 inches. And then below that, we're asked to write in standard notation. So on the left-hand side, we have scientific notation because we're multiplying by a power of 10. So we're going to eliminate that by writing in standard notation. Do you remember that the first power of 10 is 10? So we're really doing the same problem, just noticing that the notation, right, one of those notations has a hidden 1. So this one has a hidden 1. And so we're going to end up with the same answer. On the right-hand side, we're asked to solve, and we're told that a pole vaulter clears 9 feet 9 inches, and the bar is raised 6 inches. What is the new height of the bar the pole vaulter must clear in inches? And then we're prompted to start by converting feet to inches. So notice here, we're reminding you that anything divided by itself is 1, and we call that an identity fraction, and we use a green box. So first, if I have 9 feet times 12 inches over 1 feet, my feet can cancel, and I end up with 108 inches plus 9 inches plus 6 inches. And go ahead and take a minute and add that up. And I end up with 123 inches. Okay. And below that, we're going to practice plotting exclusive inequalities. So that X tells me here exclusive means to exclude, which means that I'm not including my endpoints. And we see that here that A cannot equal my endpoints. And so we looked at that on our I squared page. And so that tells me that they're not included. So I'm going to use an open circle. So go ahead and take a minute and simplify the endpoints for these. Go ahead and do that. And okay, so we've simplified that. We're going to put open circles at -2 and 3 and at 1 and 3. And then we're looking for everything that's in between. My A is in between, so everything that's in between. I'm still talking about the real number line, and my labels are integers. So now, as I said, if we were in community, we would spend some more time working through these, but we are going to go ahead and first remind you of your resources. In community, we would say these out loud together. So I'm just going to remind you of these, that we have the solutions, the inside back cover, the careful calculations, answers, and there we go. The flashcards, the companion, and the lesson pages. And then a reminder of all the different places that you can get support through the companion, the forums, your community and tutors. Now that people are doing the same math curriculum, think of all the help you have in your community through email, and then the book club, whether it's the archive or live. So this week we are looking at addition and subtraction, and next week we will look at multiplication and then division. And let me go to a blank page and we will ask questions. And Nicole, I told you you could be first from lesson 2. So go ahead and let me know what your question is.
Okay, great. So I actually think, well, okay, so I was working through lesson 2, and I don't necessarily think this question is just for lesson 2, but we came across some things where when we went, so the great thing was that we went to the answer key to find the answer, and then we would work backwards from there. And I liked that when it worked. The question that she would ask, that we were asking, was, okay, here's the answer. How would I have figured this out if I didn't have the answer key? Now that I know the answer. And there were a couple of times where we just really would have not been able to figure it out, which made her give up sooner the next couple of times, because she was like, it might be another one of those ones where it's not, you can't do it unless it's in the answer key, unless you work back from the answer key. Can you speak to that about, like, is there, I'm trying to find the one that we really,
I know that we do have one known issue on page 11 and then on page 15 where it says to write the equivalent decimal digits. And you're not really given enough information. And we have actually already updated that those problems in the next edition. And we do acknowledge that in those cases, you don't have enough information without looking at the answer key. Once you look at the answer key, you might go, oh, well, I know how to do that. I see what they were looking for now, that we were just counting in 2 different bases. But as they are that was just a problem that snuck by us before we went to print. And so we apologize for the confusion that one's caused. Is there another example?
Well, and what that was on page what? You said 11?
11 and 15 both have. Now, I will say this, that if you had looked back at page 7, you might have said, what are they doing right? Because of the repetitive nature of the lesson pages, sometimes you can go back and look on an earlier page and see. So if you looked at page 7, where it says to write the equivalent decimal digits, you would have said, oh, okay, they're counting up in base 2, and then they're counting up in base 10 underneath that. And you may have been able to use that to help you with 11 and 15. But looking at 11 and 15 without that context, it's missing some information.
Okay, I'm not seeing right the equivalent decimal digits, but I'll take your word for that. Oh, I just spotted it. Okay, no, that's not one of them, but yes. Yes. Okay, so I will let others ask because I can't find the one that we were stuck on. But I'll make a note of it.
Send it to us though, so we can get on it in case we missed it. And the other thing is also why with students, especially when it comes to equivalencies, some of them are right out of the chart. And it's more a exercise to go read the chart and just copy the answer.
Okay. Okay, I'll look back through it and make note of it. I was trying to find it just now and I can't. I just spent the last 10 minutes not listening, trying to find it. So thank you.
All right, other questions? And you can, this is a time for any question.
Okay, I had another one just with pages 7, 11, and 15 with the right equivalent decimal digits, and you were telling us we didn't have enough information, which is a relief to me because I saw that and really didn't know what to do with it. When my families, if they ask me, because I'm a director, if they ask me this week, what do we do with something like that? How do we know we don't have enough information? Like, how do I guide them? Because I'm still trying to figure out how to count in any base other than base 10. How would they know, or how would we know by looking at it that I don't have enough information? Let me find out if this is an error. Like, what do I say to them?
So I would say, perfect example of, well, let's just go ahead and look at the answer key and see if that helps us figure out what we're supposed to be doing.
Okay.
And in this case, it should be helpful. Although there's another error on the answer key, which we really feel bad about this problem.
Is that error in the answer key related to these exact same problems?
It is, yes.
Okay.
Then I would say, okay, that still doesn't seem right. Let me go and look at the errata. And you can find the errata on the bookstore website, or there's a link to it in the companion when you click on notes on that main math map page. If you click on notes, there's a link to the errata there also. So you can look in the errata. And then if you don't find it in the errata and you're just stumped, the best thing is just to email us at the mathmap@classicalconversations.com. If it's an error, it alerts us that we need to make sure that that is corrected. And we can also let you know, hey, yes, that is an error. You can also, if it's something like that, so we have addressed that on page 11. I did address that in the companion. So that's another thing, that if there's something that we feel like, hey, we need to get this so that everybody can access it, you can go to that page in the companion, and if it's clickable, it means, hey, there's an answer here. And that's another place that you can go and get pretty up-to-date information about things.
Okay.
Kristen, the errata pages are being updated on a regular basis. So there's one that's up there, and I'm not sure exactly what the release schedule is for that. I think it's at least monthly that they're going to be updating that errata as we go through.
Kirsty, is it possible that something like this that you've just been speaking to, where you have made updates and you've made corrections, that the math map assistants could let us tutors/directors know in the forum that there has been an update made?
We can try. They are not really. Yeah, we'll see if we can figure out a process for that. Because right now the errata process is the process that we have is just keeping that errata up to date. As people, if we see that there's a common question coming in, so for example, what we just talked about with the equivalent digits, I did go ahead and address that in the companion. And in that case, I can certainly let them know to go ahead and post something. So we'll look at that.
Okay. Okay, thank you so much.
I'm going to go ahead and this may not be.
did find my, oh, sorry.
Oh, I'm going to go through the raised hands and then Nicole will come back to you. So I'm just going to go the order on my screen. So Layla.
So my question is there a way that we can approach or encourage students to approach the charts in a way that helps them not be overwhelmed? There's just so much information. And I have a student who literally can't look at the page without just shutting down regardless of encouragement. So just wondering if there's an approach that anyone has found that can help us focus on a specific part or whatever. Just there's so much information, she can't deal with it.
So one thing that I've heard people have done is they take a piece of paper or two pieces of paper and just cover up a part of the chart. And so that you only are looking at a little bit and the rest of it's covered. And at home, I would say you choose, hey, what's one thing that we're going to look at? So for example, from this week, maybe it's just that top piece where we talk about what addition is and the left and right. Or if you have a verbal student, maybe it's just reading those definitions. So maybe you cover everything up and you just look and say, okay, let's read, what does it say an add-end is? So for you as a parent to choose what are some, either the visual things that I want to help them look at or some words that they could read, and then looking through that, again, a subset and helping them just like we do. Okay, well, what are some things that you notice here? Can you read these words? Great. If you can read these words, let's start there and start building our vocabulary. But covering it up is probably one of the best solutions for students who are overwhelmed.
Thank you.
You're welcome. Kaylee?
She might be gone.
All right. How about Nina?
Yes, my question's about the charts as well. Oh, sorry, I was muted by myself. So, sorry. I have a question about week 29. As a director, how can we track the progress of the student to make sure they are actually working on each week, or at least they are working on that week 29 booklet?
So that's really going to be something as far as the parents are going to be able to decide, and you don't have necessarily the responsibility to make sure that they're working on it every week. I will tell you from our pilot programs that the first year through the math map, a lot of the students didn't work on it until the end of the year. But a great thing that you could do is maybe bring into your exordium, just take a minute and say, hey, what did, everybody share one thing that they saw this week that you might want to add to your 29 booklet. So that way you're not necessarily checking on that, but you could encourage them to be looking for things and then just sharing verbally in class.
Remember week 15, you'll be showing them your booklet. And so if you're working on yours, there's time built in for the seminar because you're preparing for the book to show them, look, this is what I've been seeing all year long. The first year through, this first semester in particular, the students don't know what we're talking about when we say week 29. So just don't need to have that expectation. So if you can get a few things into your own book this semester, and then next semester, they'll say, remember, you can say, remember the booklet I showed you? You have one. See, they'll register with them. Right now, then register with them. So, and then they can, you can be more concerned about doing some of the things Kirsty just said.
That's a great idea. Thank you so much. We are on the week 3, and then a lot of parents already give up a lot of things, and because of overwhelming by the volume, I think, and then they haven't get used to it. And as a director, I also feel the pressure because I feel like I need to cover more during this during the seminar, and 1 hour is definitely feel like not enough if I work on the week 29. So thank you so much.
I think of it like a buffet, right? If you go to a buffet and you load up your plate with something from every station and then you eat it, you end up being really sick and never wanting to go back to that buffet again. But if you go through and you pick a few things and you might go, oh, I really like that, I'm going to have that again next time, right? But the next time I can also sample different things, right? And so that's where we think about less is sometimes more, because we really get to enjoy what we're doing. So the math map is designed, you know, we keep saying this, it's designed to really empower parents to teach math at home and for them to tailor the program to their student. So there is more, right? We all know that there's those families out there that will do everything and they'll do it really well. And the rest of us will go, wow, look at them. But that wasn't my family. And I think Lee would say it probably wasn't her family. And Babs and Jill would probably say it wasn't their family, that we all had to pick and choose. And some weeks we might choose different things. And so I want you all to really feel empowered to not try to do it all, because that's not really the intent. Nina, what was your question?
So my question is with the charts, I guess in my mind, like I love the charts and because I like charts and essentials. So, and now that we're doing flashcards, I'm seeing all the things overlapping. Like the charts that are in these early weeks that we are really flipping back to them to complete the work and to have conversation. I've been trying to decide, do I leave them in the booklet or take it out? But now as I'm listening to today, I'm guessing like the charts from the first few weeks, we aren't necessarily going to use always in the coming weeks. They're a great resource. And in my mind, that meant, well, I might use all the charts on a week. But would you say that's maybe not the case?
Yeah, so you probably won't, there are going to be times where you're going to be like, I remember where that was in the chart. Let me go and look that up. So we do recommend that you, after you're finished with that week, that you pull that chart out and you put it in a notebook so that you have access to it. Because there may be times where you look back and you're like, oh wait, I wanted to look that up. So for example, for me, there's things in lesson 6, division, where I'm like, oh, what's that formula again for right, completing the square, or right, I want to go back and make sure I got a formula right. So I might go back and look at those charts. So there, I like having them in one place so I can go back and use them as a reference. But you are going to be focusing mostly on the chart of the week each week. Does that answer your question?
Yes, thank you so much.
Great. Beverly.
Hey, so I actually I posted in the chat because I wasn't sure if we'd get to it. It's real quick. It's an Exordia idea kind of question. Can you are there ideas for how to use, like in week 4, the back Exordia page, the hundreds chart, and then back on week 3 was the scales of justice page, and there's no explanation for how we could use that. I'm a director in class. I'd love to get some ideas for those.
So they really aren't intended for use in community. So
I thought that was our exordium page.
No, your cover is going to be your exordium. So you're talking about just like we do here. So you're going to use your art and your quotation and your reflection as your conversation exordium. And then for 10 weeks, you're going to play National Number Knockout. The middle 10 weeks, you're going to look at 10 interesting integers. You can choose them, or you can use the ones that we've given you. And then the last 10 weeks, you're going to use some games actually from quick flip arithmetic with a deck of cards. So just quick 1 to 2 minute games or exercises that you're going to use in class just to warm up their brains, their math brains. And then those games are really designed for use at home.
Okay. Thank you.
Oh, you're welcome. All right. And Nicole, I told you I'd come back to you. Are you still here?
I am. A lot has happened in the last 10 minutes in my house, but yes, so I found the place that we were actually excited to be able to figure it out, but then we wanted to know, like, did we miss it in the beginning, right? So it is page 4, and it's the part that says complete the set of operations. So the one question we had was the second one. Are you supposed to write 1/2 twice? Are you supposed to write what's the other one? 3/5 twice? Or is it asking what do these two sets have in common? And so we kind of guessed and we ended up getting it right, and we looked at the answers and we're like, okay, so it's like asking what these two sets have in common. But we couldn't figure out how we would have known that if we hadn't looked at the answers. And then the other one was the next one.
Sure.
And the
Yeah,
C, that was it. The C stands for, we've been saying complex. We've been writing complex for all the C's. And so I had to say, I think that C is complement, which means like everything that's not in there. But she was trying to figure out how she would have known that if I hadn't known that.
Sure. So that's where looking at your chart is going to be helpful. So if you look at chart 2-4, the universal set, that U is defined there as the set that contains all the elements. But you're correct, and it does not include duplicates. So it's just all the elements that are in both sets. And then below that is where we define the complement, and that's that C, the A with the C there, and that is the set of elements that are not in the named set. So that's an example of going back and looking at the chart is going to be helpful there. Now, I'm going to point out, right, that we're all jumping into complex as our first experience in the math map, and that will always be true for some students. But eventually also we're going to have students who have been through several domains of the math map. So some of these questions, you might feel like, oh, my first time through feels like a lot, but the booklet's also being written to map to all of those other domains. So take some of that pressure off. If you're like, I had to go and look up the answer key, it's okay. Because if you were to look at perhaps the other domains, that may have been something that would have given you a hint, right, if you had worked up through that. So just to give you a little bit of take the load off if you feel like I didn't get it all the first time.
Okay, so yeah, we did look at the charts, but I think we didn't make it all the way to the 4th page. So and my son I have a son doing naturals and a son doing fractions. So I see that. I see that they will be more familiar by the time they get to this place with the charts. So I see that coming, and I'm excited about it.
Right. And it's not always perfect. So let me preface what I'm about to say. It is not always a perfect correlation, but we have made an effort in general that pages 1, 5, 9, and 13 correspond to chart 1, 2, 6, 10, and 14 to chart 2, 3, 7, 11, and 15 to chart 3, and 4, 8, 12, and 16 to chart 4. So if you're going to look at the charts, that would be the place I would start looking. Like on page 4, I would start on page 4 of the charts to see if my answer was there.
Okay, that is very helpful. Thank you so much.
Well, thank you, everybody. I appreciate you guys all spending this time with us, and I know we've been going over to get through everybody's questions, but I appreciate your patience with us as we do that. We're so glad that we can offer you help. Because that was my first conversation with was that she wanted to be able to help people and support people as they taught math at home. And there were restrictions, right? When you're using other people's curriculum, we can't come and do this with somebody else's intellectual property. So that was Lee's very first comment to me, was how much she wanted to be able to support families. And so I'm glad that you're here so that we can support you. Have a great week.
Thank you.